Okay, let's go over practice tests. Okay, this page basically talks about just kind of about a nitty-gritty electron, proton, neutron level things. What's the difference between, nitrogen and nitrogen ion and that kind of stuff. So let's just go ahead and go over these. Okay, this first part here is similar to the worksheet I had given you, series of worksheets. Okay, one's on ions, one's neutral. Very, very important to distinguish. Are these ions which needs charges, and ions, protons and electrons are not equal. That's why they're charged. So on this here, the top little piece are neutral, and the bottom one is an ion, or ions. So make sure you reflect that when you're doing the okay, and when you do ions, you need to make sure you're doing like with oxygen. What's the atomic number for oxygen? 8, right? Okay, so 8 goes down here, and then you look at the isotope 18. So there's no difference there from the neutral one except for charge. And this would be oxygen 18. Okay, and let's fill this out. Why is that a 6? Let's just look at when technology cooperates.
You right there.
Hmm?
Right there.
Let's just start at the top. Okay. All right. Atomic number 17. Remember, protons and atomic number are always equal, no exceptions. And that's 17. Oops. Oh, that's 17. This is 46. What element is element 17? Okay, so that's 17 on the bottom, and atomic mass is 29. That would be chlorine 29. About 46. What element is 46? Hmm? I was thinking of something else. Okay, so that's 46 on the bottom. And what is the atomic mass for that isotope? We need to calculate it. So that's protons plus neutrons. Okay, so that's what, 116. Okay, neutrons for chlorine, okay. Protons plus neutrons is 29. We have, of those 29, 17 are protons. So we're looking at what, 12 neutrons? Because it's neutral, these are equal. Okay, so that would be the top one. Now, this is an easy way to get points on this test, is making sure you're comfortable with this table. Okay, let's drop down to the next one now. What's different between these two? Okay, these are going to be the same, just like above. This is P plus N, like above. What's different are electrons, only electrons. Protons never change, only electrons. Okay, so oxygen has got 8 protons. Atomic number is 8. Atomic mass for that isotope is 18. So that means we've got 10 neutrons. And what about electrons? How many electrons are there? We have 11 because we have 8 protons. That means we have 3 extra electrons. So we have 8 protons. That doesn't change. And this would be then oxygen 18 again. Okay. 23. What's 23? That is. Okay. What isotope is it? Well, we have P plus N, so that's 43. That's vanadium 43. Um, should be 30, huh? Okay, atomic number is 23. Same as protons. What's the charge? Plus 3. Because we have 3 more protons than electrons. Okay, and then oxygen is going to be 8 and 18. Okay, so that's the chart. So yours is going to be similar to this. You know, both ions and neutral. Now, a lot of people last semester fell down on this part. Make sure you add the isotope number and the number of protons on your symbol. Okay, how is an ion different from a neutral element? Ion, protons does not equal number of electrons. That's with an ion. And for neutral, protons equals electrons. What are the 2 types of ions? Cations, positive, anions, negative. Okay, what's an isotope? isotope same number of protons, different number neutrons. Because if you change the protons, you change the elements. So the protons have to be the same. What's different is the neutrons, and that means the mass of the isotope is going to be different as well. Because those neutrons are going to be adding mass. Okay, so nitrogen has got 7 protons. 7 plus what is 14? So that's 7 protons, 7 neutrons. 7 protons, 9 neutrons. So again, the number of neutrons differs, number of protons, thinking about my organic class, and I was just doing the syllabus yesterday for it. Protons remain the same, neutrons are different. Oxygen 18, atomic number. Periodic table. Boom. 8. Okay. N. Now, when you have a plain old M, that's the same as N0. So N0 versus N minus 2, 2 extra electrons for the N2 minus. Why do isotopes have different masses? Different number of neutrons. Protons are the same. Electrons are the same. The only thing that differs is neutrons. If an element has 10 neutrons, 10 electrons, 10 protons, what element is it? Which of those three do you pay attention to when you're talking about what element is it? Protons. So what element has 10 protons? Bless you. Okay. Similar question. This one's on charge. Okay. So we have 8 protons. That is oxygen again. And we have 8 protons versus 11 electrons. So what's the charge? -3. 3 extra electrons means the charge is -3. How can an element have 2 atomic masses? Isotopes have 2 different masses, different numbers of neutrons. Okay, remember Bohr's, we had a series of orbitals. The innermost orbital can hold how many electrons? Then it goes to 8, and it goes to 18, and keeps building from there. All right, correct the following electronic configuration. What's wrong with this?
Is the second one an extra credit question where it says what is the most important factor determining whether an ion will form? Give me an example.
Okay, that one I was going to cover, but I didn't cover. That has to do with you add electrons or take electrons away from electronic structure. Does it improve the stability or destabilize it? If it improves the stability, it forms the ion. If it destabilizes it, nothing happens. That was where I was going with that. And since we didn't cover that, that was the second electronic configuration lecture that we didn't get to. Okay. Correct the following electronic configuration. What's wrong with that?
Fine.
2p5. So you can correct this a couple different ways. One is just to rewrite it with 2p6. That's one way. And then if you want to keep the same number of electrons, you decrease the 3s to 1. Or leave it as 3s2. So I corrected it, and they're both correct now. So you can do either one, whatever one makes the most sense to you. I like to keep it the same number of electrons. That to me makes more sense, but I also give you credit if you just, all you did was update the P in there. Okay, write the electronic configuration for aluminum. Okay, aluminum is 13 electrons. And it's in the third row down, or shell 3. And how far into 3p is it? 1 in. That's electronic configuration for aluminum. Now I want you to, before we go on, I want you to be able to do a D one also. So let's do the electronic configuration for cobalt. Okay, so cobalt is sort of in the fourth shell, but not. Remember the D's are down 1? So instead of 4D, it's going to be 3D. Okay. And how far in is it? 7 in. So practice doing D elements to be able to write. We're not going any lower than that also. Okay, any questions on the cobalt? The D part is the tricky part. And we're not doing F's, but F's are even trickier because they go down by 2. If I asked you this question on the test, what would you write? What are the 2 types of periodic tables?
Oh, yeah. I'll point that at it.
I don't know where.
It's the
On the left.
F's. The F's, F block differs. And it depends on, in 1947, did you walk out of that American Chemical Society meeting, or did you stay? Now that's, the question is not going to be in the test. It was very this is an international science meeting. This is very controversial. And they were just, this is the way it is, or this is the way it is, nothing in between. So the compromise was, well, let's just have 2 periodic tables. That was the compromise. Okay, so we have gas problems now. What's the temperature in Celsius? Now be careful. Celsius is not Kelvin. What's the temperature in Celsius of the following gas-filled balloon? Okay, we're going to be using V is equal to nRT. Know that formula. R is going to be for atmospheres and 0 degrees Celsius. It's going to be 0812. Okay, so what's missing here? We have pressure, we have volume, we have R, and we have moles. Temperature's missing. So let's solve for T. Okay, does everyone see how I got that? Okay, so we have 1.23 atmospheres. 36 Kelvin, yeah. No, it changes. It depends on the units we're using. Instead of atmospheres for pressure, say we use millipascals, another pressure you've never heard of before, but anyway, commonly used, or millimeters of mercury, that's commonly used. It's kind of going out of style now, but it's still pretty so, and that R will change each time. Because it's based on the units only. For the units, the common units that we work at every day in chemistry is 0812. And that's why I like to stick with that. Okay, we need Celsius from Kelvin. Which is higher? Celsius or Kelvin? Number ones. Kelvin, the number. Because remember, Celsius is always 237 above Kelvin. So we need to add 237. 273, not 237. That was a dyslexic moment. Okay, so what is that? That's 309C. Now, if you wrote down 36, I would give you partial credit. Okay. This one is we have changing conditions. Changing conditions, we're going to be using the initial and that's the other formula for gases to know. Okay, so what do we know here? We want to know the final volume. And it'll be in liters, and we need to convert it to milliliters. Okay, so, and remember Celsius, we need to convert to Kelvin. So 23 is 306. I do that wrong. 6, no. To 96 Kelvin. Now, in your next class, they may say 273.12. If you're in 1A, it's going to be 0.12. If you're in 2A, it's going to be just 273. It depends on what class you're taking next. But it's basically the same thing. 0 Kelvin is absolute 0. Minus 273 Celsius is absolute 0. Okay, so then we have 65. So that is 8. 338, right? 8, 13, yeah, okay. All right, so we have the two temperatures. We've got moles stays the same, so N cancels out. Atmospheres, atmospheres change. So so atmospheres went up a little bit. Volume. What did volume do? Okay, the initial volume is 4.5. And what's the final volume? Question mark, right? All right, so we've got all the parameters there. The only thing we didn't mention are moles, because moles don't change, so those go away. So we just. Now, the important thing is, everyone see where I got those values? They just come right out of the word problem. Now, if temperature remain the same, that cancels both sides. So if anything remains the same, leave it out of the formula. Okay, so we're looking at the initial volume is 4.5. Initial pressure is 1.3. Initial temperature is okay. Okay, final volume is, we don't know what that is. Final pressure is 1.4. And final temperature is 338. Okay. So we're going to solve for V final. Cross multiply. So that's, okay, this goes there, and this goes there. So we have 296 K, 1.4 atmosphere. Um, and okay, notice here now, K's cancel, atmospheres cancel. What does it leave you? Liters. What are we trying to calculate? Liters. Okay, so just grind this out. Okay, so we have one of each problem tomorrow. One where conditions change. The other one is you're going to calculate a certain set of conditions. What's the volume? What are the decimals? Yeah.
Are we converting to the?
Oh, yes, we are. I didn't read the problem very well, did I? Okay, so we're going to multiply by 1,000 to go to milliliters. So that's. So yes, we're going to definitely go to milliliters. Now you can write that out with 4,800, or do it in scientific notation. Okay, and that's, I'll give you a periodic table. And that's basically your test tomorrow. Now, in my opinion, test 3 is the hardest. Test 4, in some ways, is easiest, because by now you're really comfortable with equations and all this stuff. Now, if this was test 1, you'd die. You really would. So most people feel test 1 is really hard when they take test 1. Then as the semester progresses, they look back on it and go, but anyway, it's going to be much easier, in my opinion, than test 3. Okay, so any questions about any of these problems? Okay.